Welcome. Welcome to Presto, you got it, where we use insight for comments and analysis to make your learning easy, interesting, and fun. In addition, on academyforadvancedstudy.com, at a very affordable price, we offer many tutoring programs to help you. We cover SAT, ACT, AP, all the college prep materials. Of course, we cover many K-12 subjects. We even cover college level materials. Again, at a very affordable price. We offer tutoring programs in advanced topics such as statistics, computer science, data science. We also cover programming and engineering, Python, Java, JavaScript, HTML, CSS, everything you need in the age of AI. If you want to go to medical school, we can help you too. Again, at a very affordable price, we offer tutoring programs to help you with your MCAT. Now, let's go back to our talk today. Today we're going to talk about two very important concepts. Mean squared error. That's our first concept, and root mean squared error. So we're going to actually duplicate this video, so you will have two identical videos, one for mean squared error as the part of a title. The other one is the root mean squared error as part of a title. This way you can easily search, index, and reference if you need to. This will make your learning more efficient and much easier. So, okay, we will first start with mean squared error. Last time we talked about mean absolute error. Yeah, it's nice, it's good, very straightforward. We just need to calculate the difference between the actual value and the predicted value for each entry. And then we once we have all the absolute value of these deviations or difference, we will sum them together and calculate the average. Then we will have this mean absolute error. The key thing here is that with this approach, we actually treat every difference equally important. So the difference that is small does not have a higher weight or lower weight than the difference value that is larger. This has some implications because with this we may have a model that behave in a way that can produce very large errors in some situations, but sometimes it can behave perform quite well, but in other situations it may produce very large errors. So that's a problem we need to deal with. The way to fix that is to introduce this concept of mean squared error. The key thing here is we square the error. By squaring, as you know, the larger difference, larger deviation will be amplified. So because this is the error function we use to evaluate the performance of our model, and the model is built in such a way to minimize error. Here this error amplifies the larger difference, so the result of that will be a model that give more weight to the smaller difference and less weight to the larger difference. Well, you can see it in opposite ways. It depends on how you view this. But the key thing here is that the outcome of this exercise will be models that will constantly produce errors, but it's very unlikely to produce very large errors in the that can cause serious troubles in some situations. So that's why we introduce this mean squared error. And we will summarize for you here really quick. Again, the mean absolute error matrix takes all discrepancies between predicted and the actual labels into account equally. So the key thing here is that equally. That's mean absolute error. It behaves in such a way, but a lot of situations we don't want that. We don't want that all the discrepancies being taken into account equally. So, however, it may be more desirable to have a model that is consistently wrong, by a small amount. So that's a key thing. Yeah, it's not a good idea to have a model consistently wrong, but if that wrong portion is small, most of the situations, actually all the situations compared to alternative, then it's actually much more desirable than one that makes fewer but larger errors, because you have no idea how it's going to behave. If you make your decision based on that, you may incur large trouble, large losses. So one way to produce a matrix that amplifies, as we talked about earlier, larger errors is by squaring the individual errors and calculating the mean of the squared values. This matrix is known as the mean squared error. Somebody was having great time, so they invented something really fancy here. So again, mean squared error, or MSE. In our ice cream example, the mean of the squared absolute values, well, it's not necessary here to have an absolute value now, because we have a squared, then it will take care of the negative portion of this problem or issue. So what we have here in this example for ice cream sales, for validation data set, we're going to have a squared value of 499149. Let's go back to our data table here to see if that's what we have, 499149. Right, so the first entry, 52 temperature, the actual sales 0, predicted value 2, 0 minus 2, we have negative 2, negative 2 squared, we have 4. So we do not need to worry about absolute value here. The next entry, 67 temperature, 14 actual sales minus 17 predicted sales. So we have again negative number, minus 3. Minus 3 squared, we have 9. Next one, 70 degree, 23 minus 20. Here we have a positive difference, that's 3. 3 squared, again, we have 9. So 499 so far. Next, we have temperature 73, actual sales 22, and prediction 23. So 22 minus 23, we have a negative 1. Squared value of the negative 1, we have 1. Next, we have 78 degree, 26 minus 28, we have negative 2. We square that, we have 4. Last entry, 83 degree. So we actually sold 36 ice creams, and the prediction was 33. So we have positive 3, that's a difference, and square that value, we have 9. So that's how we arrived at this 499149 value here under mean squared error, and we calculate the average. The number is 6. So here, well, 6 you think, wow, 6 is larger than mean absolute error, 2.33. yeah, your intuition is correct, and that's something we need to fix. That's why we introduce another very fancy term, root mean squared error, or RMSE. Yeah. Next time we're going to do better with the 5 letters. So the mean squared error helps take the magnitude of errors into account. And what it means here is that we no longer treat all differences equally, because we do not want to make larger errors. We are willing to make small errors all the time, but we do not want to make unexpected large errors. So that's why we have this mean squared error, but that's a big but. But because it squares error values, the resulting matrix no longer represents the quantity measured by the label. The quantity measured by the label is the number of ice cream sold. So, but here we squared that number of ice cream sold. What does that mean? When we have a square, we know the side of the square. We square that side. We are going to have an area of that square. But here, what does that mean for us to have a squared value of the number of ice cream sold? So we cannot relate to that. It has a meaning, but not a meaning we can relate to. In other words, we can see that the MSE of our model is 6, but that doesn't measure its accuracy in terms of the number of ice creams that were mispredicted. So yes, it measures accuracy, but it's not in the terms of the number of ice cream that were sold or mispredicted. So 6 is just a numerical score that indicates the level of error in the validation predictions, but we cannot relate to that. If we want to measure the error in terms of the number of ice creams sold, we need to calculate the square root of the MSE, which produces a metric called, unsurprisingly, for once, root means squared error. So in this case, we have square root of 6, which is 2.45. This is much closer than the 2.33 from the mean absolute error. But the nature of these two matrices are quite different. So 2.45 ice cream really emphasizes that's something we can relate to. It's the number of ice creams, not the squared of the number of ice creams. Alright, so that's all we have today. I hope you enjoy this mean squared error and root mean squared error. And remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, at a very affordable price, we offer many tutoring programs to help you. That's all we have for you today. Thank you. Have a great day.